Okay, so this is called the average value, average value. And what the average value of a function is, okay, or for definite integrals, is given by a formula. And then I'm going to try to explain what it means. Average value of a function is equal to 1 over b minus a times the, whoops, that's not an integral symbol, is it? Doesn't it make you feel smart when you start drawing integral symbols and stuff? Why do you start doing like double integrals, partial integrals, or partial derivatives and stuff? Anyway, so this is the definition of the average value, okay? And it's very similar to the integral of a function, but it's not the same thing. What you do is you take the integral and then you divide by b minus a. What's b minus a? What is b minus a? Yeah, it's the range or the interval of the function. So say for instance, here's a and here's b, and the integral gives you the area underneath that curve, right? Well, the average value is the value. So this thing, okay, the average value of that function is the, let me think if I draw this here. Where can I draw that? Let me draw it like over here. Say that the average value occurs right over here. Right? What it is, it's the height of a rectangle, right? Where if this is the this is average f, it's a y value first of all. So it's the y value that when I multiply that y value by the width of the interval, it would give you the exact area underneath that curve. So it's the another way to express it kind of in words is the height of one rectangle with, it's equal to the height of one rectangle with a width of b minus a, which is equal to the integral from a to b of f of x. Yeah. In other words, if the average value, if I find some height right here, right, and I multiply by b minus 8, I would get some area, right? That area is exactly the same as the area underneath this curve. Because here, do you see that I'm cutting out some of that area by taking that average value? And over here, I probably didn't draw it in the right place for this function. And over here, I'm actually adding some area by finding that average value. Okay, so it's the height of a rectangle that would give you the exact value of the integral, is what the average value is. And that's kind of important. Like say you're a rocket scientist, you know, and you want to figure out what's the average speed of your rocket. Well, you could graph the velocity function, and you can see that your rocket's going faster, faster, faster. Maybe it levels off at some point, right? What would the area underneath this curve, if this were time, represent? If this were a velocity function, what would the area underneath that curve represent? The distance traveled, right? If I find the average value somewhere in there, okay? So say I found this average value in there. What would this average value represent in the case of the rocket traveling through space? It's average what? It's average velocity, right? Average velocity of that function, okay? So that's, you know, or if you're like working with energy or something, the amount of energy you put into, I don't know, heating something up, right? What's the average number of units per hour that you're using to heat this thing up, or anything like that. So the average value becomes very important for real life applications. So let's do a problem. Good? You got that? We're good? Okay. So so given find the average value. So here's a question. Find the average value for the integral for the function f of x equals 4 minus x squared on the interval 0 to 3. So what you're going to do, you're just going to set it up like this. You're going to go from 0 to 3. And you're going to go 1 over the width of the interval, which is 3 minus 0. And then in here, you're going to take the integral of the function, 4x squared, 4 minus x squared dx. That's all. Okay? And as of right now, we don't learn by the end of the period how to do this algebraically. Okay? Because this is a pretty easy one to do algebraically. But right now, we're just going to use the calculator to do that average value. Oh, first I'm going to hide this. Sorry. So, so if I were to graph this function, right, what shape does this make? 4 minus x squared. It makes an upside down parabola, right? Which goes like this, and then it goes actually down, and it doesn't curve back up, it keeps going down. And this is the point 0.04, and this at 3, what is the y value of this function? If I plug in 3 in here, negative 5. So at 3, so here's the point 3 comma negative 5, and here's the point 0.04. So if I were actually trying to find the value of the integral, it would have some negative amount here and some positive amount here. And so what I want to find is what I'm trying to find here is the y value of a rectangle that would give you this piece plus this negative piece. You understand that? Okay? So right now I don't know how to do this integral by hand, so I'm not going to do it by hand. I'm just going to use my graphing calculator. And I'll refresh some of your memories, okay, on how to do this. U, always in front, close these. So I already, I'm going to hit enter to make it disappear. And I'm going to go back up here and hit enter to make it come back or something. Could I do that? Is it, wait, maybe I should enter again. If I hit graph, here comes my function. No, it doesn't. I must have turned it off. Okay, so now I'm going to hit graph, and there's the function. Like I said, it looks like what I said. And remember how you calculate the finite integral? You can go second calc and go to 7. And then you're going to go the lower bound. In this case is 0. So I'm going to go 0. And then I'm going to hit my upper bound, when in this case is 3. And I get out that the value of that integral, the area between those two curves, this is a positive amount, this is a negative amount, it comes out to be 3. Right? So the value of this right here, from here to here, not is equal to 3. So my average value is going to be 1 over 3 times 3, which is equal to 1. Okay? And what does that represent? that represents, if I were to draw a rectangle, okay, with a height of 1, okay, and a width of 3, okay. Whoops, I missed. This area is equal to this piece minus this piece, right? Because what's 1 times 3? 3. Right? Follow that? So the average value is 1. The value of the integral is 3. So you have to divide by the width of the interval. Now, does f actually take on this value at some point in 0, 3? So what I have to do to figure that out is I have to solve this function 4 minus x squared and set that equal to 1. Because I want to see if the x value of that function lies when y is 1, what is the x value? So I'm going to solve this, subtract 4 from both sides. Negative x squared equals negative 3. X squared equals positive 3. X equals plus or minus the square root of 3. But since negative isn't in this interval, I'm going to choose square root of 3. So is square root of 3 between 0 and 3? Yes. Therefore, does f actually take on some value take on the value of 1 at some point between 0 and 3?
Yes.
Yes, it takes on the value of 1 when x is equal to the square root of 3. So, not to be confused, the x value is square root of 3. The average value is 1. So it's the y value. So at this point, square root of 3, comma 1, this thing is the average value. Not the x value, but the y value. Okay? So 1 is the average value, not square root. Got that? Okay. Good. We're done with average value, I think. We'll do some more when we learn how to take antiderivatives. So, next thing, I didn't talk about this yet. Where'd all the time go? Mean value theorem for definite integrals. This just states that there's always going to be some y value if the function is continuous. So it's kind of the same thing. All it says is that if f is a continuous function, continuous function on a b, then should be a comma. Then at C in A B f of C equals 1 over b minus a times the square of the integral from a to b of f of x dx. Okay? And so all this said, it's exactly the same thing as the average value. Mean value theorem just states that there's always going to be, if the function is continuous, we don't have to prove that there is a value in there. There's always going to be a y value there's always going to be a y value, there's always going to be a point C such that its y value is the height of a rectangle, whose areas would give you the integral, okay, the area underneath that curve. So it's just saying that you're always going to be able to find some average value, okay? So, and then they'll ask you in your homework, find the average value of this function. All you have to do is take the integral and then divide, okay? So the next part, I think I'm going to stop, because, can I stop for a minute?
Yes.
Okay, thanks, Kate. Why am I stopping? Because